Welcome to The Ohio State University. It's a real pleasure to see so many of you here today. My name is Kathann Kress, and I have the pleasure of serving as Vice President for Agricultural Administration and Dean of the College of Food, Agricultural, and Environmental Sciences. So it's my pleasure to, along with the Ohio Beef Council, welcome you to this event today. Back when colleges like ours were founded, Abraham Lincoln referred to them as the People's College. And that's how we still think about them. So I want to welcome all of you essentially to your college. Our central mission throughout our 3 campuses, here on the Columbus campus where you are today, our Worcester campus, and then what we think of as our statewide campus that includes all of our research stations and farms and our 88 county extension offices, we have one fundamental mission, and that is that we sustain life. Our college is dedicated to an incredible industry which seeks to simultaneously assure viable agricultural production, food security and safety, and environmental and ecosystem sustainability. It's the simultaneously that makes that difficult. And yet, through technology, through research, and through education, our industry has made significant advances. And that's what today is really focused on. I hope as you participate today that one of the things that might occur to all of you are the many ways then that you can join us in this industry. We know that over the last several years, colleges like ours have only turned out about 30,000 of the graduates that are needed to fill about 61,000 jobs out in our agricultural and natural resources industries. So we hope that all of you will take some inspiration today and think about ways that you can pursue careers in sustainability and in agriculture. So welcome. It's really my pleasure on behalf of both our college and the Ohio Beef Council to welcome Dr. Sara Place today. She is Senior Director of Sustainable Beef Production Research at National Cattlemen's Beef Association. Her role there is to oversee the Beef Checkoff funded sustainability program, including using life cycle assessment to benchmark the United States beef industry's sustainability. Prior to joining NCBA, she was an assistant professor of sustainable beef cattle systems at Oklahoma State University, the other OSU, for 4 years. She had a split research and teaching appointment there. At Oklahoma State, her research program focused on the measurement of enteric methane emissions from cattle, and her teaching responsibilities included animal nutrition, dairy cattle, science, ethics and professionalism, and sustainable animal agriculture. She has also served on the National Academies of Sciences Committee on Considerations for the Future of Animal Science Research that published the report, The Critical Role of Animal Science Research in Food Security and Sustainability. Dr. Place received her PhD in animal biology from the University of California, Davis, and her other degrees are from Cornell University and Morrisville State College. Please join me in welcoming Dr. Sara Place.
Thank you very much, Dean Kress, for that kind introduction, and thank you to the college for inviting me here and for the Ohio Beef Council for sponsoring this event. Really excited to speak to you all today and really excited to see all the young faces in the crowd, so hopefully you all get a lot out of this presentation. So what I'm going to talk to you today about is how beef fits in a sustainable food system and some of the issues related to what is a sustainable food system and all the complexities that go into that. So starting off, what are some of those complexities, right? When we think about sustainability, often what we think about is really trying to find a balance between 3 different areas, right? And I like to think about it as a Venn diagram type model. So essentially there's economic issues, there's social issues, and there's environmental issues. And we're trying to find some sort of sweet spot where we're balancing all these different items, okay? And this can be really difficult because we're trying to balance things as diverse as nutritional quality, right, in terms of what we're eating, animal welfare, right, thinking about culture and traditions of both producers in terms of the people that produce food and eaters, right? All the different environmental issues that we can think about, from land use to greenhouse gas emissions, and the affordability of food, right, and rural livelihoods and rural economies. So I just want to put this up here as a preface that there is, a lot of times, there's just no one right answer when it comes to sustainability, right? And that's what's really key, is what's over here on the side, right? We all have our own value judgments. We all have our own ways that we're going to weigh these different items, right? Maybe to you, what's most important is animal welfare, and that's fine. That's good, right? But somebody else will have different priorities, and that's what makes it challenging when we're talking about sustainability. So also to set the stage a bit, right, and this is really important when we're talking about beef cattle production and beef in a sustainable diet, how does beef actually get produced in the United States? So the life cycle of cattle is a little bit complicated compared to some of our other animal products in the U.S. Essentially, there's three main segments to the U.S. beef industry, and you guys can see those illustrated here. Most of our calves that are going to end up as beef animals later in their life start out in what's called the cow-calf sector of the industry. Okay? That's really diverse because it happens in all 50 states. So what works in the East Coast is a lot different than in, say, Arizona, right? But what is unifying of this sector of the industry is that it's really forage-based. For the most part, all the cattle in this sector of the industry are grazing cattle, right? With the exception, of course, when we're in the wintertime, in some parts of the year, there isn't green grass to graze, right? So they may be eating hay, for example. From there, when calves get weaned, so they get weaned somewhere around 6-10 months, it depends on the production system, they're going to move on to the next segment of the industry, and this is what we call either stocker or backgrounder. In this sector of the industry, the animals are also eating a grass-based diet or a forage-based diet if they're in a feeding situation, a confinement situation. So again, this just kind of extends out that whole time that they're eating grass. And then what maybe you're familiar with is the finishing phase, right, of the beef cattle production system. And really, this is where when you hear about grass versus grain finished, this is where the production cycle splits. Okay, so this is where grass and grain finished are a little bit different. Grain-finished cattle are going to be eating a grain-based diet. They're not eating 100% corn when they're being finished, but they're eating a grain-based diet, typically corn in the United States. And then grass finishing, the animals are either going to be truly grazing or they're going to be eating a forage-based diet in a confinement situation. So again, that's really where the two things split. And I just want to put this up here to give you guys a little bit of background information, but also I'm probably going to come back to using these terms later in the presentation just so you have those in your back pocket. So when we talk about beef consumption or meat consumption and sustainability, I think it's always important to know where we're at in terms of how much beef do we actually eat in the United States, okay? So what we're looking at here is information from the USDA Economic Research Service, and this is essentially availability data, right? So it's not truly consumption, but it's what we assume has disappeared and people have eaten in the United States, okay? And this goes all the way from 1909 to close to present day, and this is in pounds available per person per year in the United States. So there's lots of different colors on here, so just to point out a few items, right? The red on the bottom, this is beef availability, okay? So what's taken place over 100 years compared to 1909 to where we are today, we're essentially eating the same amount of beef, or we have the same amount of beef available per person, okay? So we peaked in the mid-70s, and we're roughly where we were 100 years ago today, okay? Total red meat, so that would be beef plus this blue is pork, and then these other two are lamb and veal. So right now we're not eating a lot of lamb and veal in the United States. Okay, but total red meat consumption is also pretty similar to where it was 100 years ago, and is down from a peak in the mid-1970s. Okay, total meat consumption is up, but really what's driven that, and you guys have read the headline at the top of the slide, right, is poultry. Right, so we eat a lot more chicken in the United States now as compared to in the past. And that's what this green section is, right, is chicken consumption or chicken, again, disappearance. Now, I want to put the caveat out here that consumption is not demand, right, so those are two different things, but this just gives you an idea of what we're actually consuming in the United States. So that's the U.S. situation. What does it look like globally? Okay, so this is similar information, again, availability. It's our best proxy for what we're actually eating. And this is in also expressed per person per year, okay, for global situation. So I put this up here because we often think about what's called like the 2050 challenge, right? You guys are probably familiar with that, right? We're somewhere around 7.7 billion people today. We're going to hit about 9.8 billion in 30 years, right? So adding 2 billion dinner plates in the next 30 years. And so oftentimes what we hear about is meat consumption is going to grow, and that's absolutely true, right? People get more money in their pocket. One of the first things they do as we have this growing global middle class is they improve their diet, and that often means increasing the amount of animal source foods that they're consuming. But I put this up here just as a reality check of that mix is probably not going to be just the same for all the different animal proteins, right? If we look at the last 50 years as a trend, right? So what we have going on here in the yellow, this is bovine meat, okay? So it's actually pretty flat in terms of consumption per capita. Of course, total production and consumption has increased with growing population, but the amount we eat per person in the world has been pretty flat. What's changed is pork and poultry. So again, these are the other two lines, essentially what we call monogastric animals, okay? So those are our pigs and our chickens. Those are simple-stomached animals, and so those have grown at a more rapid pace as compared to beef globally. So again, that's just kind of setting the stage to understand where we've been and what our consumption actually is. So now I'm going to get kind of into, excuse the bad pun, but into the meat of the presentation, okay? And start talking about some of these things that are related to some of the stuff you'll hear about beef consumption or production and sustainability, okay? The first being is how much feed it takes to produce beef. And when we think about feed consumption and what cattle are actually doing, we like to think about this word upcycling, okay? So if any of you are on social media or Pinterest, right, you probably see upcycling with regard to recycling furniture or things like that, right? Taking something of literal no value and making a higher value product. Well, really that's what cattle are doing too. So cattle, they're more than simply recycling, taking something and making something of equivalent value. They're taking all these feed resources, right, that are grass, or hay, or feeds that are inedible to humans, and they're making a really high quality product, okay? So when we think about how that actually works, this is really key, right? They're taking solar energy that's locked in these plants that are mostly human inedible, right? We can't eat them. And when we run those through cattle, we're able to produce a high quality food product, and of course, all the other products that we get from cattle, right? From leather to pharmaceuticals to all these other things that we derive from cattle, and of course, it's a similar situation for all of our animal industries, okay? So this is really important. I'm going to pause here and say this is really key, and this is unique for cattle because they are ruminant animals, right? So I threw out that word monogastric earlier, so a simple-stomached animal. Ruminants are very different from you and I in terms of their digestive system, right? They have one stomach, but it has 4 compartments. And the biggest compartment of that stomach is called the rumen, and that's why they're known as ruminant animals, right? So our cattle, sheep, and goats, our farm animals, those are all ruminant animals. What's unique about them is they have this unique symbiotic relationship with all these microorganisms that live within their rumen, okay? So when we feed cattle, or especially people that are ruminant nutritionists, when they're formulating diets for cattle or other ruminants, they're actually thinking about how can I feed these microorganisms in the animal's gut, and how is that going to affect the animal's whole health? So that's super important because those microbes are what allow cattle to eat this wide array of feedstuffs. And that's why I put the solar energy up here. This is super important, right? Most of the solar energy that hits planet Earth, it gets trapped in a compound called cellulose, right? Fiber. That's most of the energy, solar energy hitting Earth. And there is no way for us to get any nutritional value from cellulose without these 4-legged critters, right? Cattle, sheep, and goats. So that's why they're super important, is they're able to unlock solar energy that we don't have available to us without them. So the other thing that's surprising to people is what cattle actually eat. Grain-finished cattle actually eat over their lifetime. And that's what this little donut chart is here down in the bottom of the graph. So this is a breakout of the life cycle feed intake of cattle in the United States. So this is some work that's been done over the last 4 years. So in my role, as you heard earlier, we do what's called life cycle assessment. So we've surveyed over 2,200 producers across the United States and understand what are they actually feeding their cattle. Okay, and so this is really the breakdown of that. So 82% of what grain-finished cattle eat in their lifetime is not grain. Okay, it's forage. And hopefully that makes sense as you think about that life cycle I showed you earlier, right? Cattle are spending 2/3 of their life on grass, eating forage. And so that makes up the bulk of their diet. Another 7% of what they eat are what we call byproduct feeds, or essentially plant leftovers. So this is things like distillers' grains from corn ethanol production, cottonseed from cotton production, and then a whole wide array of essentially leftovers that come from processing crops for human food, right? Or even spent human food or foods that aren't to spec, like bakery waste, right? Bread and bagels will get fed back to cattle and other livestock. And then about 11% of what cattle eat, grain-finished cattle eat, is actually grain, right? And so that's really super important. About 90% of what they're eating is not in competition with the food supply with you and I, right? So this is really key when we think about, as I referenced earlier, right, feed efficiency and how we express feed efficiency. And so this is a little bit of math for you all early in the morning. But it is important because there's lots of ways we can express how efficient you're using feed to turn it into a product. And this is an example of 3 different ways of showing that, and you can see how the ranking changes when we do that. So, up top here we have grain-finished cattle, and again this is from our life cycle assessment of U.S. beef, broiler chickens, and pork. Okay, and the first column is just pounds of feed, and this is a dry matter basis per pound of product, right? Live weight gain, excuse me. So we have beef, broiler chickens, and pork. Okay, and again, this is a life cycle number. This isn't just a feed yard conversion. So usually people will stop here, right? And if you look at those numbers, right, your conclusion is going to be, well, cattle, they're pretty inefficient. Like, look at how much more feed it takes to produce a live weight pound, right? So this is pretty simple, right? We should just be shifting our production more to those monogastric animals. However, what's important is we're not taking into account what I just showed you on the previous slide, right? Most of that feed is not human edible. Really, it's not in competition with the human food supply, both from the standpoint of the land base it's grown on or directly, right? We can't eat hay yet in America, and I don't think we're going to be able to. So when we take that into account, that's what's on this middle column here, okay? So this is the pounds of human edible feed that these animals are consuming. Now, the caveat here is, of course, this is mostly corn and soy, especially soy for these other 2 critters, right? You probably don't want to eat field corn, right? A lot of you are pretty familiar with that. You don't want to eat it directly, but if you had to, you could, right? So we're classifying it this way. What's really interesting is when you express it this way, all those dramatic differences across the species kind of go away, right? It's a similar feed conversion efficiency across all 3 species. So this third column, this is a little bit different. This is a little bit tricky to think about. So we've been expressing feed conversion as what goes in versus what comes out. This is flipping it on its head, okay? Essentially saying, what is the value of the product, in this case beef or pork or chicken, to the human food supply in terms of the protein that it's supplying, okay? So you all know we need protein in our diets, but it's not just the protein, we need the essential amino acids, right? These are like the building blocks of protein. And there's certain ones that we have to eat every single day. And so this is saying how much of these essential amino acids are in the product that are available to people versus what's actually being consumed. And so, as I have in this little parentheses here, if we have a value greater than 1, that's a good thing for this ratio, okay? That means we're generating more human edible, high quality protein from the system than the animals themselves are using. So with that background, right, you guys can see beef is above 1, right? Well above 1 in terms of what we're producing as compared to our other animal proteins. So why is that? It really comes back to this soy issue, right? And ruminants versus simple-stomached animals. So pigs and chickens, they're like us, right? They have to eat high-quality protein every single day, okay? And so the feed resources that go into those systems tend to be of higher quality from a protein standpoint. When we think about ruminant animals, again, because they have this unique relationship and they're carrying all these microbes with them around, those microbes themselves are an awesome source of protein. And so they don't have to eat as high a quality a diet, right? And so that's really what separates out these different species. So the trade-off with this, right, there's all these advantages of ruminants. This is one of the trade-offs, okay? So you heard earlier enteric methane in my introduction, which is a weird term, right? What the heck does that mean? Enteric just means from the gut, and methane is a greenhouse gas, if you're not aware, right? So methane is about 28 times more potent at trapping heat than carbon dioxide in the atmosphere, okay? So methane naturally gets produced in these animals' rumens, okay? So as they're digesting all this feed, you guys are familiar with other fermented foods or fermented beverages, right, that may have bubbles in them, right? So it's a similar process that's taking place within the animal's gut. They're producing all of this gas, and they have to remove it about once a minute, okay? That's a process called eructation. What's key, if you take one thing away from my talk, right, is just know it's cow burps and it's not cow farts, okay? It all comes out the front end of the animal, right? That's super important. The other thing, and often a misconception, is that when we're feeding animals higher fiber diets or more grasses, more hay, that means more methane, okay? More fiber, more methane. When we have more fermentable carbohydrates, more grains, that means less methane. Okay, so when those animals go into the finishing phase of their life and they're eating a grain-based diet, if they're corn finished, they're making less methane, right, as compared to when they're consuming grass. So the second thing I'm going to talk to you about is this issue of land use, right, and thinking about how much land it takes to produce beef, but really, kind of already alluded to it, right, that cattle are essentially expanding the land base that we have available to produce food. They're using land that's unsuitable for cultivation, and sometimes they're enhancing ecosystems or providing services other than just the food. And a great example there is eating grasses, especially in western rangelands, and we've had some bad fire season the last couple of years, right? Removing some of that forage can help mitigate or lessen the risk of really out-of-control wildfires. So when we think about land use, I think it's always good to have a visual, okay? So this is a really interesting map. It's from the American Farmland Trust. They're a group that's interested in the loss of farmland due to urbanization, suburbanization, right? Putting up strip malls and old cornfields and the loss of that land. And so really this is what all these red splotches are all over the map, right? That's our urban areas, and those areas are called peri-urban. That's where we're losing a lot of farmland. And so again, that's what this group is concerned about. But what's also on this map is a good visualization of the different land use types. That's information from USDA. So the dark green, so cropland, of course that's a significant portion of Ohio, the Mississippi River Valley, right, the Central Valley of California, that's our cropland. That's where we're really good at growing row crops, it may be corn and soybeans, or if we go to California, it may be all the different specialty crops that we grow, right, from almonds to lettuce, et cetera, et cetera. The other colors that are on the map I want to draw your attention to is this light green, so places like in eastern Texas, and then this orangish color, right, rangeland and even this federal land that's grazed, and that is most of the western U.S., and there's this light green interspersed all throughout. So that is our pasture and our rangeland. And this is land that is, for the most part, it's too arid, too rocky, too steep, too highly erodible for us to actually use for cultivated agriculture, to use to grow plants that we like to eat directly as people, if that makes sense, right? That's what's key. So the only way for us to use this land in terms of growing food, right, this is a huge area, it's about 40% of the lower 48, is with ruminant animals, right, is with cattle, sheep, and goats. Right? That's the only way that we can generate human food from that land and convert, again, that sunlight into something that's usable. What's also important to this, and I'll just be brief on this, when we think about sustainability, soil erosion is a really key issue, right? And it sometimes gets left off. It's not quite as sexy as climate change and everything else, right? But it's absolutely fundamental from a standpoint of producing food and producing it in the future. So this is just a table showing Soil erosion rate changes over time, different types of erosion, so sheet and rill erosion, essentially from water, right, and wind erosion. And the main thing to call out here is, of course, there is erosion on pasture lands. There can be serious erosion on pasture lands, but the rate of erosion is about 5 times lower on average as compared to our cropland, right, especially cultivated conventional tillage cropland. So that's another important sustainability issue, and if we think about switching land use types and, right, the consequences of that and what would happen with soil and soil erosion. So the last thing I'll say about land use and for beef production is it's really complex and it really varies across the United States, right? So these are some pictures just illustrating this. This is from Florida, okay? So if you're not familiar, Florida is a big beef production state, right? It's number 10 in the nation for beef cows. Okay, so this is about 30 minutes from Walt Disney World, okay? And this animal, obviously, when I put this up here, one, this is what you're not going to see up here in Ohio, right? This is more of a Bos indicus type animal because it's hot down there. And the other thing is this animal's sharing land with wildlife, right? And sometimes we talk about land use like there's only one thing happening on a given acre, and that is not true, right? We have a lot of land sharing from a wildlife perspective, but then we also have really unique integrated systems where our crops are integrated with livestock in the United States. And so this picture down here, this is actually wheat grazing, right, in Ohio, or excuse me, in Oklahoma, the other OSU, right, in my time there. So what's unique about this system, if you're not familiar, right, winter wheat gets planted around September. The wheat will grow. Cattle oftentimes are brought in to graze the wheat for a few months. Cattle will be pulled off. So one single acre of land is providing feed for cattle, and then when those animals are removed and the wheat's combined, human food, right? So that's a really unique system where, again, we're using 1 acre for multiple things. What's also super important is when that wheat gets milled into flour, we get lots of byproducts, right? I kind of alluded to that earlier. Wheat middlings is one of them, which is really great cattle feed, right? So it's kind of this closed loop system of these things getting recycled and upcycled, if you will. A couple other examples. So this is in Minnesota. This is a family, I just think they're really impressive. They're really focused on soil health and organic matter, and they are crop farmers, but they use cattle as really a tool to enhance their soil and enhance their system, right? And having that crop rotation and having cover crops and using the animals to actually graze them is super important. So again, there's lots of integration, and then this is just a picture showing you down on the U.S.-Mexico border, actually in Arizona, this rancher, Dr. Dean Fish, he and his father have been managing this one property for over 30 years. And what he's doing is going out with what's called a transect, okay? And actually counting and looking at the number of plants that are in all these areas, which sounds like kind of a boring job, right? But it's actually super important because these are type of the things that our ranchers do is they're actually measuring what's going on with the plant communities on my acreage, right? And that's important to know how well are you doing from a grazing perspective and what should you change, right? You can't manage what you don't measure. So the third thing I'm going to talk to you about is just how the U.S. compares to the rest of the world in terms of beef production. A lot of things I'm going to talk about kind of translate to other parts of agriculture too, even though this is a beef-focused talk. And just how we've changed over time in terms of shrinking our environmental footprint in the United States. So just to start off with a global comparison, what this map is showing is essentially carbon footprints, okay? So this means greenhouse gas emissions, all expressed as carbon dioxide equivalents, okay? I won't go into that, but just greenhouse gas emissions per unit of beef protein produced around the world. So if you can't see this scale down here on the bottom, what you need to know is these darker green colors, like in North America, in Western Europe, that's where we have lower carbon footprints, okay? The lighter green, like in South America, that's where we're kind of intermediate. And then the purple areas on the map is where we have carbon footprints that can be 50 times greater than they are here in the United States, okay? So why? Why is there such huge variation around the world, right? A lot of it comes down to the number of live animals it takes to produce beef. And by live animals, I don't just mean the animals that go to become beef, right, that get slaughtered, but all the cows, all the bulls, what we call replacement heifers, all the supporting herd that's needed to generate beef in a country, okay? So just as an example, the United States, we're the #1 beef producer in the world. And so in 2017, we had a cattle herd of about 94 million head, and we produced 26 billion pounds of beef, okay? If we go to Brazil, they're the #2 beef producer in the world. They produced about 21 billion pounds of beef, but they had a cattle herd, all beef and dairy cattle combined, of about 220 million head, okay? So that's twice as many cattle, and they make less beef than us, right? And so again, hopefully that makes sense what I told you about these belching cows and everything else, right? If you have more cattle and you need more supporting resources, you're going to have a higher environmental impact per unit of beef. So I just want to also call out, obviously, in some of these countries, in sub-Saharan Africa and India, we have unique cases, right, where animals are either held for reasons other than meat production, right? They may be held for equity, right? They may be used for draft power, for fuel source, right? Cow dung is still a really important fuel source in lots of parts of the world. So I don't want to put this out here as like some parts of the world are better or worse, right? It's variable. It's very variable where we're talking about. So this is important because this whole idea that what I've been talking about, the live animals to produce beef, it comes down to this whole concept of productivity in agriculture, right? Doing more with less, essentially. And so that's super important when we think about this 2050 challenge I mentioned earlier, right? How are we going to produce enough food, enough protein, high-quality protein for people, but also not compromise our natural resources, right? We only have one planet Earth, right? We can't just expand land bases and everything and have negative consequences, right? So this is just a scenario here looking at what happens in terms of the change in the global cattle herd if we have different productivity scenarios, assuming 9.8 billion people. So again, that's that 2 billion plus more people that are coming to dinner in the next 30 years, right? So what's going to change, most likely on the path we're currently on in terms of productivity and how much beef people are eating? Like I told you, it's flat for 50 years, so I doubt we're probably going to increase after that. So we would have a cattle herd about 7% bigger by 2050, right? This is a future projection. Probably I'm wrong, but this is our best guess, kind of back the envelope calculations. But just to show the power of productivity, if we could achieve the rate of beef productivity that we're achieving in the United States, or the rate of improvement every year, we could have a cattle herd that's 27% smaller than today and actually nourish 2 billion additional people. Right? That's huge. This scenario is probably not going to happen, but it shows you the power of it. What if we could actually be as efficient as we are in the United States all around the world for all beef production, right? You could have a cattle herd that's half the size of today and produce a lot more beef, right? So again, that's the power of productivity and doing more with less and how that's so related to sustainability. Right? So I've talked about greenhouse gas emissions a lot. What's super important is just to kind of put it in context, right? Like how much greenhouse gas emissions are coming from beef cattle in the United States. Okay, so this is information from the US EPA. So every year they put out a greenhouse gas emission inventory, right, every April. And so these are the direct emissions that come from cattle. So that's mostly that belching of methane and any emissions that come from their manure, okay? So it's about 2% of greenhouse gas emissions is what comes from beef cattle production. To give you a frame of reference, all of agriculture, all crops and livestock is about 9% of emissions in the United States. Transportation is about 25, 26%. It bounces around per year. Electricity is around 30%, okay? The other thing I want to draw your attention to is landfills, right? They're roughly equivalent to what gets produced from cattle. And so what that is landfills, they're a source of methane too, right? So when we put all that organic matter in our landfills, we throw our trash away and we don't think about it ever again, right? There's a lot of methane that gets generated in that process as well. And I want to highlight that because when you think about the whole food system, right, zooming back out, the #1 source of organic matter that goes into landfills is food waste, right? So we waste a tremendous amount of food in the United States, edible food. So we put all these resources into producing food and then we throw it away. And that's really important for beef, right? Because we have a long life cycle. It could be up to 2 years of investment to get a steak to your plate, and so when you only eat half of it at a restaurant, you're like, nah, I don't want to take it home, right? So you're throwing away 2 years' worth of resources, and then, to add insult to injury, it can produce more methane, right? So just to really guilt you out at lunchtime today, I don't want to see any food waste, right? Which, don't overeat too, right? I don't know how that really matches up, or you have both those pieces of advice. So what about changes over time, right? So things aren't static in agriculture, and of course, I'm a beef person, I'm giving this a beef talk, but a lot of similar scenarios for all of our different agricultural commodities in the United States. So what you're looking at here is two different lines, right? Essentially, the yellow is beef production, and this bluish color is how many cattle we actually have, and I'm pulling out the lactating dairy cows from this. So you can see the headline at the top. What's really taken place is, for the most part, in the first part of the 20th century, as we had more cattle, we produced more beef, pretty linear relationship. And then since the mid-70s, especially since 1980, we've had this kind of decoupling between the two, right? We're able to keep producing the same amount or even a little bit more beef with fewer and fewer cattle. And that's really been driven by science, right? And here we are at Ohio State, right? It's the science that happens at places like this, at our land-grant universities around the country, that allows that amazing improvement in productivity to happen. And that's really, really key in terms of shrinking our environmental footprint, and again, being responsible with the natural resources that we're managing, right? Doing more with less. So this is super, super important to that. And just to drive this home, this is information from the UN's database that's called FAO Stat, essentially looking at how this productivity actually affects our carbon emissions, right, or what they've estimated in this database. So this is looking at the US in 1975 and 2016, okay, and then the percent change between those 2 years. So what's going on here is this is essentially our carbon intensity, right, how many greenhouse gas emissions get produced per unit of beef, our total emissions, and then our total beef production. So the thing to see here is that our emission intensity has decreased 33%, right? And that's really been driven by the fact that we have fewer cattle, right? So we have less methane being produced, less of these resources being used, right? So that means our total emissions have been able to drop, right, pretty dramatically according to this database. These are, again, direct emissions, right, from the cattle themselves, the manure. And our beef production is pretty much the same, right? So again, that's super important. That's where productivity links up with environmental impacts. So how does this actually take place? The biggest driver, one of the key drivers, is genetics, but also things like animal nutrition and just better management, better husbandry practices, okay? But just to give you an idea, I think genetics is one of our most powerful tools that we have, has been in the past, and definitely will be in the future. And so there's really unique things that we can do, like selecting for feed efficiency, right? We talked about that earlier. How much feed does it take to produce beef? That's not a static number. We can change that, right? We can get better. And this is an example of that. So these are actually Wagyu bulls out in Nevada last year. They're eating out of a really unique system, and this is one of a few types of these systems that exist. It's called Grow Safe. Essentially what's taking place is every time one of these guys comes up to eat, what they're eating gets recorded, the weight of it. So each one of these feed bunks is sitting on a scale, okay? They have a little RFID tag in their ear, and so when they put their head in to eat, it identifies who it is that's eating, and it weighs how much you're eating and the whole meal and all the feeding behavior. It's super, super cool. It's a tremendous amount of data. It gets shot off to Canada to get processed, okay? And then what we get is super cool information like this at the end. And you probably can't see it, so I'll just read off what this is. But this is from a bull sale, as I mentioned, in Nevada, south of Reno. The lady that runs this feedlot is, she's kind of a character. She makes me laugh. You can see she's not very subtle about what she thinks about feed efficiency, right? If you can't see, those are all dollar bills, right? So feed efficiency, one of the measures we have is called residual feed intake. So this is just a measure of like, how much feed does it take to produce beef? Are these animals eating less than we would expect? Because that's a good thing, and they're still gaining well. So these are all excellent animals in this bull sale, but what she found is the 10 most efficient animals over the course of 70 days, they gained 177 pounds more weight. Well, that's pretty good. But they actually ate 15,000 pounds less feed, right, to gain more weight. And again, these are all animals that are really good from a genetic standpoint, but we have tremendous variation within and across breeds that we can select for, right? And we can get a lot more efficient. So this is super important. Again, this is one of those tools that's out there is genetics and actually measuring things and understanding how it works and keep getting better. And being implemented in the industry on commercial feed yards. So I've talked about historical changes. I like this just to put it all into perspective, right? So these are just some historical changes that have taken place in the United States from 1909 to 2015, okay? So I won't read them all off to you, but you guys can see some of the highlights here. So the U.S. population has grown 255%, right? Our life expectancy has gone from 52 to 79 years. That's a really good thing. The number of motor vehicles registered has increased 84,000%, okay? The number of motor vehicles per person has increased 27,000%, okay? And the total number of cattle, this is all beef and dairy cattle per person, has gone down 58%, okay? So I'm not an anti-car person. I'm just saying that, clearly we burn a lot more fossil fuels today, right? And that has improved the quality of life. I'm thankful that I can travel further than a 20-mile circumference in my days, right? Because now we have transportation, all these things. But it is one of those things that drives climate change is we're burning a lot of fossil fuels. So I just want to briefly touch on water, just because I know this is another thing that we hear a lot about with beef, is how much water it takes to produce beef. And so just a little bit of background there in terms of why, when you look in the literature, you'll see estimates of 317 to almost 25,000 gallons of water per pound of beef. Like, what number are you supposed to believe, right? That's a huge range. And why is it such a huge range? So a couple things. One, there's different types of water that get accounted for in water footprint analyses. So you may be thinking, what does that mean, right? Water is water. But there's different classifications when we're calculating water footprints. So there's blue water, which is essentially all surface and groundwater. So this would be any water cattle are drinking or water that's used for irrigation, right? So whether it's pumped out of the ground or used as surface water. Green water, this is evapotranspiration water or precipitation, essentially, okay? So I put this up here because typically when you see those really, really high numbers for water footprints for beef or any other animal product, it's because precipitation is being accounted for. Right? So some of these really high numbers will take that big map I showed of the United States, say, man, look at all that grazing land. All the precipitation that falls on that land, we're counting towards the water footprint of the grazing animals that are there. Right? So you can argue the merits of if that really makes sense or not, because the water's going to fall whether there's animals there or not, livestock there or not. Really what we care about is blue water use, right? And we care about blue water use if it's being used unsustainably, right? Being pulled out of an aquifer quicker than it can be recharged. That's what we really care about. So the other thing I have up here is just kind of a diagram of the beef supply chain, right? So from feed production all the way to the consumer. And I just want to point out, and this is universally true whether it's blue or green water, most of the water associated with beef is in the feed production, okay? So it's not that cattle are amazing water drinkers and they're just sucking down 24,000 gallons of water, right? They're drinking a normal amount of water. It's just the water in the feed, right? So if you're in the western U.S. and your feed resources are coming from irrigated pasture, irrigated corn, for example, the water footprint will be higher. And in this life cycle assessment that we've done of U.S. beef, we know in the eastern U.S. it's much lower because you're not irrigating, right? Your water use for beef is just what the animals are drinking. So it's a super variable issue across the United States and across the world. So the last thing I'm going to talk about here is just when we think about diet and sustainability, and I've just put this up here, be aware of one diet to rule them all, right? I'm a Lord of the Rings fan, right? So I put that up there. So there aren't a lot of easy answers when it comes to sustainability from a diet perspective, right? And while I'll show you the next few slides, I'll be kind of brief on this, but just how you rank different commodities changes based on what priority you put on something, right? So if you remember way in the beginning of the presentation, right, we talked about we have value judgments, we have different things that we can look at and emphasize, right? So it really depends on what we're ranking in terms of how that ranking goes. So one way we can do it is looking at per unit of mass or per unit of protein produced. And so this is information that comes from a 2013 report called Tackling Climate Change Through Livestock from the UN Food and Agriculture Organization. And this is looking at greenhouse gas emissions expressed per unit of protein for all these different commodities globally. Right? These are global averages. Okay? So just walk you through it. On the vertical axis here, this is kilograms of carbon dioxide equivalents per kilogram of protein. And then we have beef, cattle milk, small ruminant meat and milk, and so these are our sheep and goats. Okay? Pork, chicken meat, and chicken eggs. So a couple things to point out here. One, these are box plots, right? So what these mean is the line is where you have your mean, and then the plot is showing the variation. Okay? So one thing is our ruminant species in general, especially beef, right, and your small ruminant meat, they have higher carbon footprints than other commodities. That's just true. And that comes back to the biology of the animals themselves. Okay? They are ruminants. They belch out methane every day. They live a lot longer, right? You're talking about years for cattle and 6 weeks for a chicken. Of course, this kind of makes sense logically why the emissions are different. The other thing is that there's a lot of variation, especially in ruminant production, especially in beef. That's a huge array of variation. And I showed you that earlier on that map, right? This is just kind of a different way of showing it. So again, the United States, we're down at the bottom, but we have this huge variation across the world. So again, this is one way of expressing different environmental impacts. Or we can think about it differently. Instead of just protein, we can think about other nutrients that we need too that are essential. Okay? So this is really interesting research that came out of the UK. So this is UK specific in different production systems. So they were looking at different dietary essential fatty acids, calcium, iron, some B vitamins, right? And looking at nutrient density. So nutrient density means how much nutrients package are in that actual food, okay? And so what's interesting is when you look at it that way, now beef, if you can't see here, beef, right, compared to chicken is pretty similar, right, when we count for nutrient density. Okay, so which one are we supposed to believe or use, right? It depends on what we want to put as a priority. Here's another way to look at it. Instead of just protein, we're going to use these essential amino acids, right? Remember I told you those building blocks of protein, right, that we actually need. And so the font's really small here too, but just to show you, this is land use at the top, and then this is greenhouse gas emissions, okay? So we have different foods like eggs, pork, right? We have things like peas, wheat, maize is corn, right? So in this situation, at least according to this publication, right, beef has a lower land use than peas when you express it as how much do you have to eat to meet your protein requirement, your amino acid requirement, right? And that again comes down to the nutrient density. So there are, of course, complete plant proteins like soybeans, right? I don't want to call that out, right? You have those few that are complete, and so they still look better. But some of these plant proteins that are incomplete proteins, they don't have all the amino acids at the level we need. They're going to change ranking when we express it this way. And I won't go into all the details of this, but this is a super interesting publication that was looking at a French retailer has all these different carbon footprints for all these different foods. And so this researcher out in Washington State looked at how does nutrient density, or if we express carbon footprints different ways, how does that change the ranking of these different foods, okay? And so I won't go through all of this, but kind of the takeaways here, right? So the lowest greenhouse gas emissions per 100 kcal, or energy, were sugar, sweet rolls, grains, snacks and chips, right? So if we're using that as our benchmark to say that's good, right, we may have some other issues, right? Sugar is the most efficient deliverer of calories per low carbon cost, right? But we don't want to meet all our nutrient requirements or our energy requirements with sugar, even though maybe some of us would like to, right? But we probably shouldn't. And then this is also just from this same paper, but again, all I want to call out to you is that the rankings will change, and the vast differences between plant and animal sources will kind of go away when we start using different ways to express the actual outcomes. So I think this is super important when we think about sustainability and we think about sustainable diets, is to have that frame of reference in mind. It isn't always a straight relationship, and we have to think about the realities of our situation in America and our situation around the world, right? We still have people that are undernourished, but we have this growing issue of people being overfed and undernourished, right? Where we have too much energy and obesity, right? And in the United States, this is a paper that I put this up here mainly because I find it super disturbing. It came out in November looking at these different criteria for health. So things like waist circumference, blood pressure, triglycerides, HDL, right? Used all those to classify who's actually metabolically healthy. So this is irrespective of not looking at obesity, but who's metabolically healthy in America. And 88% of Americans, according to these criteria, are not, right? So that's not good, right, from a sustainability perspective. What's also unique about this is even people that are normal or underweight BMI, which is an expression of body weight, body mass index, still a majority of those folks are not metabolically healthy, right? And so this is really important too, and kind of the backdrop as we're talking about sustainable food that often doesn't get merged much with our discussions about carbon emissions and everything else, but it's super important. About half of American adults either have diabetes or prediabetes, right? So that's a disturbing statistic. And so that's what's really important from an animal source food perspective. They do tend to have higher footprints, as I've showed you some of those data. It can change based on how we rank them. But they also are really nutrient dense. And I think that's important to emphasize. Okay? So there's a lot of things going on this slide, but essentially what this is looking at is how animal source foods, right, are contributing to the U.S. food supply in terms of energy, protein, all these different nutrients, right? Especially ones that we need in small amounts but are very important, like vitamin B12 and zinc, okay? So the bottom line is over here on the far right. Animal products, they only provide 23% of the calories, but they're providing us 63% of our protein. And sometimes people will say, well, they're not providing a lot of calories. A lot of resources going for not many calories. We don't need more calories in America, right? I feel pretty confident saying that. We don't need more calories, right? We need more nutrients. And so this lower calorie cost to deliver these nutrients is super important, in my opinion, right? And we should emphasize that, especially B12, right? There is no B12 without animal products in our food supply. And these nutrients tend to be more bioavailable when we eat them, right, from animal source foods as compared to plant source foods. So that's important. I'm going to kind of wrap this all up. I know this is a lot of science, the first thing in the morning, so I appreciate you all for hanging with me. But this whole idea that if maybe we eat less meat or less animal source foods, it will mean dramatically fewer greenhouse gas emissions. It's not necessarily the case in the United States, okay? And so I think this paper that came out in 2017 in the Proceedings of the National Academies of Sciences really drives this home, okay? So two scientists, they looked at this scenario. They said, what if every American went vegan, okay? And not just all the human Americans, but all the cats and dogs too, right? Like everybody is a vegan in America, okay? What would take place in terms of greenhouse gas emissions? What they found is indeed we would reduce greenhouse gas emissions by 2.6%. And I put in parentheses what that is for globally. It's less than 0.5% of global emissions would be reduced. But what would take place is this kind of insidious trade-off, right? Of course, you as an individual can eat a vegan diet and be successful, but if you eliminate all animal source foods from the food supply, now we get in a situation where some of those essential nutrients are not in a great enough supply for us. We would have more calories, right? We would have more pounds of food, but we would have zero vitamin B12 in our food supply, which we need every day, right? So that's what this quote is, right? We would have non-viable diets in the United States. What's going on here with this graph, it looks a little complicated, but I just want to walk you through it, is plus animals. This is our current situation, and this big blue blob, this is animal greenhouse gas emissions in the United States. If we had no animals, I just want to point out, you don't eliminate all of this. You have to add back in synthetic fertilizer because now you have no animal manure, right, as a fertilizer source. You have to grow more legumes because we need them from a protein standpoint, but also they add nitrogen fertilizer, right, for our cropping systems. So there is no free lunch in terms of you can't just pull animals out of a system and expect there not to be ripple effects, right? And the final thing I'll say about this is this assumes all livestock would disappear. Okay, that's really important. The animals had to go away, right? They can't still be on the landscape belching out methane, or you're not going to get any of this perk of reducing emissions. And also, probably our cattle can't get replaced with bison, because guess what bison are? Ruminants, right? They also belch out methane. So this is a really complex issue, right? And I want to emphasize, this is if all animals go away, right? So this is the maximum that you could reduce greenhouse gas emissions by eliminating animal products. If you just go meatless Mondays, or if you personally cut back on your meat, more power to you to do whatever you desire to do, right? That's a choice, but you're not going to make a big impact from a climate perspective, because this is with 320 million Americans going vegan, right? So it's just, again, it's a lot more complex sometimes than it's made out to be. So I put that out there, and I know a lot of you probably are familiar with this idea of plant-based diets or plant-based foods. And just to kind of end with something a little bit tongue-in-cheek, right, and leave you with some food for thought, I would argue that we already use an amazing technology in the U.S. beef industry to make meat from plants, okay? It's a mobile technology, right, that doesn't have to burn fossil fuels, and it harvests human inedible plants, and it makes a high-quality protein source. Pretty cool. And while it's doing it, right, it's fertilizing the soil with a high-quality organic natural fertilizer. And this technology self-replicates, right? So hopefully some of you guys have figured out what I'm talking about now, right? It's cattle, right? That is the technology, right? So we could argue that cattle or meat, right, is the original, or beef is the original plant-based meat, right? So again, tongue-in-cheek, but just thinking about what we do a little bit differently, right? We're already doing these things in terms of transforming resources, using a really awesome animal to do it. The end product of 3.5 billion years of evolution, right? I'm hard-pressed to think we're going to get more efficient than that really quick, right? We have all these benefits with it. So the bottom line I want to leave you with, sustainability, it's not an easy answer, right? There isn't a single easy answer when it comes to sustainability. It's not one production system or one dietary pattern over another. They can all fit. It's just making a food system that's all about improving and getting better over time, and make the whole plate better for everyone, right? Give those choices for everyone, right? The whole range of diets. So it's about balancing environment, economic, and social issues, and really how we define sustainability for beef is safe, nutritious, high-quality beef while balancing economic viability, social responsibility, and environmental stewardship, all three. And there's not one answer even in the state of Ohio for our beef cattle producers, right? They're all dealing with a different situation. So it is complex, but it's something that's really important, right? We are all on this planet together. We do have to keep getting better, and that's why we're focused on it. That's why the beef industry is investing in this area. So with that, again, thank you very much for your attention. I appreciate, again, I dumped a lot of information on you in a short amount of time. But if you have any questions, I'm happy to take them. And also, this website that's on the screen, that's a great informational resource with a lot of this material that I presented is there. So thanks again for your really great attention. Appreciate it.
Dr. Place, we really appreciate your presentation this morning. And now I'd like to invite our participants here. We've put a mic up here in the front. Please don't be shy. Dr. Place has agreed to take your questions or elaborate further on something that might have been part of her presentation that you'd like to hear more about. So please come on up to the microphone. If you could start by stating your name and then whatever your question or your comment is, we'd appreciate it.
Okay, so if you didn't hear the question, I was referring back to that whole slide where we're showing we're producing the same amount of beef, right, or we can produce the same amount of beef with different productivity scenarios. I think it's the slide you're thinking about, right? So how can we achieve that? So some of the examples that I gave in the United States in terms of those things that got us better, got us to where we are today: genetics, nutrition, husbandry, and especially internationally thinking about things like animal health, right? Vaccines, just better animal health, reducing mortality, reducing sickness in animals, better reproduction performance of animals, which always seems weird at first when you think about how does reproduction affect sustainability. But actually having a cow have a calf every year, which is ideal, right? And shortening the generation interval, that makes a big difference, right? So it's actually a lot of those little things that come back to the basics of animal husbandry that drive productivity, right? It's not necessarily, it can be new technology, but it can be just adopting what we already know, what we have, and getting those tools and empowering people around the world, right? And so it's really complicated. There's lots of things that go in that. It could be everything from credit and capital to getting some of those technologies in people's hands to actually drive that change. Great question.
Mm-hmm. Please go ahead. Mm-hmm.
I'm Jennifer Swanger, and so another part of environmental impact of livestock is kind of manure management and where that goes. Now, how does that work regarding beef cattle?
Great. So if you didn't hear the question, it was about manure management and how does that affect sustainability. So absolutely, manure management or nutrient management is a key part of sustainability, both from a standpoint of how it affects water quality, but also, again, this whole crop and livestock integration standpoint, enhancing manure management. So there's lots of different things that our producers do. And again, I'll kind of remind you of that life cycle of beef. So there's different things they're going to do in different situations. And a lot of our beef cattle production systems are what we call extensive, right? I mean, they're grazing. And quite frankly, the animals are going to defecate and urinate if they have the access to the area wherever they are. So in that case, what a lot of our producers will do is make sure that they're fencing out riparian areas, right, or essentially around waterways, right? You want to keep the animals out of waterways so they can either, destroy in terms of causing a lot of erosion, or we don't want them to defecate and urinate in the water, right? So that's one of the ways that we manage manure from a standpoint of grazing systems. When we get into confinement systems, it's actually a little bit easier because we can actually collect manure, right? We can actually do something with it, both from a standpoint of potentially treating it, whether it's things like aerobic composting, right? Or if the producers are going to use it back on their own cropland or on other people's cropland, right, as a fertilizer source. That's what's key, is getting the timing right, when you're applying it, incorporating it into the soil, having buffer strips, all those different practices that exist. And of course, that's true when we get into confinement with beef and dairy cattle, with all the different livestock species, right? It gets a little more similar at that point.
How common would a confinement system be for beef cattle beyond the finishing stage?
So the question was, how common would sorry, my phone is going crazy. How common would it actually be for confinement beyond the finishing phase? So it depends on the part of the country you're in, right? Again, most of that confinement is going to be in the finishing phase. We do have some systems, especially in the upper Midwest, that may have animals in a more confinement situation for a longer part of the year, right? Which makes sense because, again, if you're dealing with weather, you're going to have to have animals inside. And so once those animals are in a confinement situation, the manure management situation would be similar to any situation, again, if animals are in confinement.
There's a question over here, Sarah.
Okay. Well, I'm Michaela Shanks. I attend here at Ohio State. And you mentioned genetics earlier, and I was just curious if you know of any genetic innovations or improvements that are coming around, or like any that you'll see coming in the near future.
Great question. So I think what I mentioned, feed efficiency, is something that I think is super exciting if we can really focus on that more as an industry. So we have some of those tools now, what are essentially called expected progeny differences, that our producers will use when they're making breeding decisions. And different breed associations use different ways of expressing feed efficiency, but I think that's going to be something we're going to see more and more of in the future. And we really haven't had a concerted effort as the industry focusing on that. And so I think we can actually really drive down the feed requirements for cattle by really focusing on that. And that's again, something I'm more excited about. There are, of course, all sorts of different technologies out there. Probably a lot of you have heard of gene editing, right, or CRISPR-Cas9, right? And so there are some potentials there for unique applications in cattle. The one, of course, application you probably, if you've heard about it, have seen news articles about is more related to dairy and related to snipping out the genes for horns, right, for cattle, which is actually a really unique example of using a gene editing technology for an animal welfare outcome perspective, right? Because dehorning cattle can be a painful procedure for those animals. So all sorts of interesting opportunities coming in the future, I think. But again, for me, it's even just the traditional tools of breeding, I think, can make a big difference.
Thank you for a very organized and information-rich session. What are your thoughts on the potential for intensively managed rotational systems to support carbon sequestration?
All right, so if you didn't hear the questions about carbon sequestration, about intensively grazed or intensive, like integrated crop and livestock systems, there is some interesting research that's been done on that. Some up at Michigan State University that came out, I think, last year on management intensive grazing on land that was previously hayed for several years, right? And the ability to really store a lot of carbon. I think that's an awesome area of research. When we actually do our own life cycle assessment, we're very, very conservative about what we assume for carbon sequestration. Because we're really, in my opinion, at early days in that, in terms of how do we apply these assumptions across the whole US, right? The other question that always comes up with carbon sequestration is how long, right? How long can you achieve that rate of carbon sequestration? Is it something that's really rapid and then it plateaus? We just don't know, and we need a lot more data to actually answer that question. I will say in the in the western United States, like where I'm in Colorado, we have western shortgrass prairie that has been never tilled, right? And they only get 15 inches of rain a year. And realistically, because what drives carbon sequestration is actually the living root, the living plants and moisture, there's probably not a lot of potential in those situations to sequester a lot more carbon, right? And we have information from USDA that would show that. But if you're in the eastern US and you're on a degraded land that was previously cropped and maybe a little bit abused, and you convert it back to pasture, there's probably a big potential to sequester a lot of carbon. So again, I think it's an interesting area of research that's going to keep generating results that are going to intrigue us for sure.
Hi there, my name's Amanda. I'm a student here at Ohio State. One of the main assumptions that I kind of heard towards the beginning of your presentation was that the land that is used for producing cattle feed, it's human and edible food, but what would be kind of the changes to that if we switch that land to a human edible food? Would that change kind of that assumption, and how would that impact that?
Yeah, as you're saying that, I realized I put that map up there. You probably remembered I had a big black box over Iowa, and you're probably like, why is she discriminating against Iowa? And I forgot to mention what that was. So that's a good reminder of that. Thank you. So that black box that was up there on the map, that is the acreage of corn grain that goes to support cattle. So kind of related to your question, right? That's cropland that's supporting cattle
Do you
production.
want me to find it?
Yeah, that would be good.
Okay.
And so that's what's actually super important related to your question, right? What if we use that for a different use, essentially? But hopefully if you remember what I showed you, right, we generate more high-quality protein for the human food supply by running the corn that's grown in that box through cattle than if we were to eat the corn directly, right? So of course you could grow something alternatively there, but that's just to give you an idea of that actual land that could be truly used for something else, okay? So that black box is about 8 million acres. It's about 2% of cropland acres in the United States, okay? So that's a great, I'm glad you asked that question to remind me of that. And just when we think about corn use in the United States, it's about 9 or 10% that goes to beef cattle production, okay? It's about 39% total that's going to all livestock, and another about equivalent amount going to corn ethanol production today in the United States. So that's a great question if you're a student. Hey, that's a great research question for you to ask of looking at those scenarios.
Yes, my name is Hank Webb from Clyde High School, and you talked about the 2050 challenge. So 2 billion people in about the next 30 years. Now, I've taken sociology classes and all that, and I learned that first world countries don't really have a high population growth, but it's the third world countries that are really making our population boom. So these are the countries that are less agriculturally inefficient. So what are your takes on this? What are some ideas to solve this inefficiency?
So I think what's really key there, and that's kind of related to the earlier question we had about how can we improve productivity, it's all those same things, right? It's really empowering those people that are in those countries to get better, right? I think that's really important from a food security standpoint. So you're right, it's going to be most of the population growth is going to be happening like in the global south, right, in sub-Saharan Africa, some of our Latin American countries, and of course still in East Asia, we're going to still have a lot of population growth. So that is really important. That's what our collective challenge is, right? And the reason we focus so much on protein is because a lot of those countries are lacking protein right now, right? And particularly in sub-Saharan Africa, just increasing a bit of animal source foods in people's diets can have tremendous health differences, right? And outcomes for them, positive benefits. So that is, again, it's all those things: genetics, vaccines, just improving people's ability to do well, and some of the basics of infrastructure, right? Roads that work well, and markets that function properly, and refrigeration where it's needed, right? All sorts of a whole host of suite of things can help that process. Great question.
Yeah, so speaking of graphs, if you go back to the human health graph, the bars for BMI were divided into gray and white parts. What were the white parts?
Yep, we'll go back to that. Thank you very much for
trying to
moving
find
the
it.
slides.
Yeah, this.
Okay. So if I recall from the paper, it is 2 different criteria for these 5 metrics, right? So if you're really interested in that, I would write down the information that's there, and you can check that paper out and really dig into it, because this is like one slide summary of a really complex paper, obviously. But yeah, so this is I think, again, like 2 different cutoffs, either more conservative, less conservative. It was what was going on there.
Hi. Oh, sorry, I'm over here.
Oh.
My name's Leanna, and I have a background in ecology, and I'm curious. Like, I know grassland needs a grazer in order to be like a healthy ecosystem, and cows are one way of getting that. But I know that they move along the land and graze differently than bison do, and so I'm curious what your thoughts are about maybe using bison and converting to a system of meat using bison instead, where they're grazing the land the way that it used to be. And also that means like more meat per individual, which you were kind of talking about in your presentation is like a sustainable thing. I know there's complications with like genetically pure bison and select few parks having brucellosis, and non-genetically pure bison maybe being different, but I'm curious what your thoughts are on that.
Yeah, so that's a great question. There are obviously is a renewed interest in reestablishing bison in a lot of the Great Plains, right? And there are some groups that are doing it up in Montana. The Nature Conservancy down in the Osage of Oklahoma, right, has a bison herd down there. So it's an interesting opportunity. I think there's going to be some more of that, people thinking about restoring the prairie. In terms of the research on grazing behavior, it's kind of a bit mixed. It depends on how you manage the cattle, really. How well you're managing stocking rate and how frequently you're moving the cattle in terms of how they're affecting the grass population. So there's some interesting research. There was an interesting paper that just came out this past year from Sam Follendorf and others at Oklahoma. I keep trying to say Ohio State, right? Oklahoma State, that you may find really interesting on this whole concept of rewilding, and maybe you're familiar with that.
Yeah, I was wondering, because I've heard there's been sort of a movement towards like reestablishing like cowboys and like, humans that move with the cattle and kind of direct where they're grazing and things like that. Do you know any sorts
Yeah,
of
so
stuff
there's
about
a lot of that takes place now. I will say, as somebody that grew up in the eastern U.S., I grew up in upstate New York, right? When I first went to the West, I was like, wow, cowboys are still a real thing, right? Like, and that is still happening, right? And so we have a lot of those people that are still practicing those kind of pastoralist practices, or transhumanists, which is a cool word, right? That's what it's called, right? Moving with your animals, both with cattle and sheep, right? So it really just depends on the landscape and the productivity of it, of how that management breaks down. Those are good questions.
There was a question here, I think. Yeah. Okay. One there and then up here too, John.
Hi, my name's Leo Almeida. I'm with the Nature Conservancy in Ohio. I had a question about grass-fed beef. So this is something that is popping up here and there, even in Columbus, places that are selling grass-fed beef for burgers. And I'm wondering, for one thing, is it big enough that it's making an impact on the industry, or if it's just a fad at this point? And two, is the carbon footprint less for grass-fed beef compared to finishing or
Yeah.
grain finishing beef?
Yeah, great question. So in terms of total sales, at least from the retail data that we have, it's like less than 2% of total beef, right? So it is a small market, but it's kind of more, as you said, right, it's more of that direct-to-consumer type marketplace is pretty popular with grass-fed, right? Or people buying halves or quarters of beef. And some of these new online systems, like things like ButcherBox or whatever, if you haven't heard of it, right? Some of our grass-fed producers are using those kind of avenues. So it's another choice that's out there for consumers. In terms of carbon footprint, typically when you look at life cycle assessments, actually grass-fed tends to have a higher carbon footprint than grain-finished. And I'll explain that a couple ways. One is just that length of time it takes to get the animal to finishing, to actual point of harvest or slaughter, is usually longer for grass finishing. And again, every day they're alive, they're belching out methane. And then the carcass itself, the weight that they produce tends to be less, okay? That said, that paper I referenced earlier at Michigan State, right, they found really high rates of carbon sequestration. So when they factored that into their study, they found that helped to lower their carbon footprint, right, to a lower level. So it all depends on this carbon sequestration question mark, right, that's out there and what you can actually achieve. But that said, as I mentioned, right, I mean, that carbon sequestration potential, that's for all beef, because it's all really grass-based, it's all really forage-based, the industry itself. It's just that finishing phase that changes.
Hi, I am Brad Collins. I'm a beef producer in the state of Ohio, and so I see a lot of these new clean meat brands and products sort of claiming that they're more sustainable than, regular beef. Is there any truth to that?
Yeah, so good question, and I will say, so when we think about some of these alternative meats, there's essentially two different categories, right? So there's the cultured meats, which are essentially mammalian cell cultures, right, that is meat-ish stuff, right? I do work for NCBA, right, so I'm not really that keen on it. But that product or those products, they're not commercially available yet. So some of those companies that are working on those products make claims about sustainability, but quite frankly, we can't make an assessment because there's no commercial process, right, to even compare it to. And all I'll say about that is most likely their fossil fuel inputs into a system like that are going to be pretty high, right, because you're not using sunshine and grass, right? You're using synthetic inputs to make a product. When it comes to more of the plant-based alternatives, right, they've been there forever, right? I mean, we've had veggie burgers for a long time. The ones that are trying to make it more like a meat texture, some of them do claim carbon footprint advantages. But again, I think it's just important to zoom out to that whole picture, right? The inputs going into that burger are also not 82% forage, right? They are peas and wheat protein and soy protein, right? And so it gives people another choice. But what's interesting is a lot of those products are processed, right, from crops, and they create byproducts, right? And if you look at the ingredient lists of some of those alternative burgers, I would argue probably, even though they don't want to admit it, some of their byproducts are being fed back to livestock, maybe even cattle, right? So I don't think they're going to claim us as making them more sustainable, but maybe, right? We're taking care of their waste. So it's just a lot more complicated than that. And I think there's true advantages against ruminants that you just can't get with anything else, whether you're eating plants directly or whatever it may be.
Hi, Thank you so much for such an informative talk about the sustainability of beef. I'm Luann Hendricks. I'm a student at Ohio State, and I had a question. You hadn't addressed animal welfare in your talk, and so especially in our U.S. Industrialized food system, we treat animals as units of production. So, for example, cattle are social animals, and when the calves are weaned, they're taken from their mothers, and there's a lot of animal welfare questions. So is there any initiative in the industry to address some of these?
Yeah, so right off the top, we do have an initiative called Beef Quality Assurance. It's been around for a couple decades that is based on educating producers on best management practices, including handling and welfare. And that guy that I showed you that's doing the transects on the rangeland, Dr. Dean Fish, he's one of our experts that goes on a traveling roadshow to do stockmanship and stewardship seminars. And I think you've had one here in Ohio, at least one, essentially where we bring in behavior experts, right? You're probably familiar with Dr. Temple Grandin, right? She's at Colorado State, right? So between the management side in terms of how you work with animals and understanding that better, and also facility design, that's absolutely a priority for the industry. Some of the things you mentioned about calf separation and stuff, of course, cattle get weaned, beef cattle get weaned. But of course, they're getting weaned at like 6 months of age, right? And we have lots of research on different weaning practices, things like called fence line weaning, where you separate the cow and the calf, but they can still see each other, right? And that helps lower the stress that the animal experiences. So it's absolutely a priority in terms of measuring that. We have different people at universities all across the United States, including Ohio State, that focus on animal welfare science. And I think the industry recognizes all these environmental issues are important. They get more media coverage, but animal welfare is a higher priority. It's a higher priority for our producers in terms of doing the right thing. It's also a higher priority, I would argue, for all of us as consumers, right? Because we kind of care about that maybe a little bit more in terms of thinking about animal welfare. So I didn't cover it in my talk, but absolutely we're working on that. We have staff that's what they do, is beef quality assurance.
I think we have time for one last question.
Goody. Hi, my name's Samantha Adams, and I'm going to take a step back to the forage. As the population continues to grow, and I'm hypothetically 50, 60 years into the future, how will this affect the farms and the forage that the cattle intakes into their diets?
So I think your question is kind of getting at this whole idea of how much land are we going to have, right, available. So I think realistically, that's one of our key challenges globally for agriculture, is not expanding too much more, especially into forests, right? And the classic example is the Amazon, right? And trying to keep that in check. I think in the United States, we're in a really good situation in terms of the natural resources that we have. And because we have a lot of opportunity, even here still, to do, again, more with less, while paying attention to welfare and all these other important aspects, right? I think we're going to be in good shape. I'm much more positive on that whole scenario. Sometimes people are a little more negative, like there's no way we can do it. I just think that's a very negative attitude, right? All these times in the past, we've stepped up and met the challenge, a lot of it through science, right? And as a scientist, I believe that we can do it in the future, so thanks.
Great. Please join me again in thanking Dr. Place.
Thank you.
I would also like to thank Elizabeth Harsh, the Executive Director of Ohio Cattlemen's Association and Ohio Beef Council, for your partnership in making this possible today. We really appreciate it, Elizabeth. The recording, by the way, of this presentation will soon be available on the website for our college. So I encourage you, if you want to go back and check it again, or if there were friends of yours or others who could not be here today, please share that information with them, that they can view the presentation online, and it will be posted shortly. I encourage you all to stick around for a little bit. There will be some beverages available out in the lobby. We thank you again for coming, and I hope you found this presentation productive and helpful, and go Bucks.